Welcome to Study Loop.
Okay, so the question says that a proton of charge plus E and mass m enters a uniform magnetic field. So the magnetic field is uniform and it is directed towards x direction and it has intensity of B. So B I hat, and says that the initial velocity V is oriented only in x and y direction, and the strength in x direction BOX V0x is, or V naught x is V naught x I hat plus V naught y j hat. So this is the velocity. Now the question is asking us to find the expression for velocity at any later time t. So v at any later time, at any time t depends upon what? Depends upon the acceleration, right? If there is acceleration, so the velocity changes. If there is no acceleration, no change in velocity. So it depends upon a and further depends upon F, that is the force. So let us find the force first. The force on the particle on the proton is due to the magnetic field, and that is given by Q times the cross product of velocity and magnetic field. Let us consider at any time t, at any random time t, arbitrary time t, let us consider that the velocity v vector is equal to vx times I hat plus vy times j hat in y direction plus vg times k hat. Okay, then the magnetic field will remain the same. There is no change in magnetic field. It is uniform with time as well. So bi hat. So this gives me the expression for force F will be equal to Q times P cross B. So Q times V cross B. If you cross product these terms, then we get three terms where I cross I will be 0, and j cross I will be minus k, and k cross I will be j. So let us write that here. Minus of b vy and k hat plus b vz, and that is j hat. Right, so this is the force at any time t. So at any time t, the velocity were vx, vy, and vz, right? The components in x, y, and z directions. So accordingly, the acceleration will be dvx by dvt, dvy by dt, and dvz by dt. So let me write that here. Force is the product of mass and acceleration. So m times, m is the mass of proton, dvx by dt in x direction plus dvz, sorry, dvy by dt in j direction. This is the acceleration along j, and dvz by dt, this is the acceleration along z, right? So this should be equal to, again the same, so let us compare each components, like the components in x should be equal to the components of x in the RHS. So if you component the I hat terms in both sides, so we don't have any terms with containing I hat in the right hand side. So if we compare the sides, then we get m. So let me write it. We start with dvx by dt. So it says that dvx by dt equals to 0, right? This is equation 1. The other equation says that dvy by dt, comparing the components of y direction, okay, that is j hat, it will be equal to minus, no, it is plus, so q b by m vz, right? This is equation 2. Now comparing the components of k hat, this will give me dvz by dt equals to minus qb by m vy. This is equation 3rd. All right. Okay, now our task is to solve this equation at any time t, right? To solve this equation, the first one is very simple. The first one from equation 1, vx equals to constant. Very easy. So velocity along x will be always constant. That is always how much? This is the velocity along x-axis. This is always constant at time. So this will be equal to vox. Right? So we are done with the x component of velocity at any time t. You can also figure this out with by another method. The magnetic field is along x, so there will be no force on the velocity that is along x, because the theta, the angle between velocity and magnetic field, is 0. So there is no force along x, so no acceleration along x, hence the velocity remains constant, and the differential equation also shows that. Now to solve 2 and 3, equation 2 and 3, I used Mathematica to solve equation 2 and 3. So it says that if I solve equation 2 and 3, here is equation 1 here, and here is equation 2, sorry, equation 2 and equation 3. So this gives me the solution to vyt and vzt, right, where I have substituted omega is equal to, or w is equal to qb by m for simplicity. Okay, so if you solve these two equations, this is now equation 2. Okay, let me check. Let me write that at equation 4, because we have already written that the differential equation is 2. This is equation 5. So let us find out this constant from 4 and 5. The question says that at time t equals to 0, there is no velocity in z direction, right? And in y direction at t equal to 0, okay? So this is 0, and 0 equal to how much? What is the velocity? v0y, right, at time t equal to 0 at initial time. So using this scenario, using this condition in equation 4 and 5, we get from 4, what do we get from 4? vyt equal to 0, so vy0 equal to 0, v0y. So let us use the first condition first. vz0 equal to 0, so 0 equals to, from equation 5, 0 equals to c2, cos 0 is 1, so I don't need to write anything here, minus, now sine is also 0, so c2 minus 0. This gives me c2 equal to 0 from equation 5. Now from equation 4, if you use that these conditions in equation 4, then that gives me what? v0y equals to c1. Now c2 is 0, right, so nothing is left, so this condition gives me c1 equals to v0y. Now using both these values in equation 4 and 5 give me Vy of t equals to C1 is what? V0y. So V0y cos omega t, and Vz of t equals to minus V0y sine omega t. So we found all the components of velocity v, that is Vx here. Here is the Vx component of velocity along x direction. Here is Vy, here is Vt, right? So just combine these all now here. Finally, V equals to, at any time t, equals to V0x in x direction. In y direction it is V0y cos omega t j hat, and in k direction it is minus V0y sine omega t k hat. So here we found out the velocity v at any time t. This is the solution for this question. Thank you for watching.